Greetings and welcome again to the Smart Video Lab. This time we're going to be talking about factoring trinomials. Um, so again, a trinomial has three terms, and we're specifically going to look at trinomials in standard form. So that means starting with the term that has a degree of 2, and then going to the term that has a degree of 1, and then to the constant term. Let me use the different colors so you can actually see. So whenever I have a trinomial in standard form, I can always try this method to factor it, and we're going to call it the x factor method because I have this red x here that I'm going to use. Now, the red x is just a graphic organizer that helps us organize our thoughts. So once you've filled in the x factor, don't fall into the trap of thinking that you're done, because graphic organizers are just used to help you organize your thoughts. Once you've done that with the graphic organizer, then you have to write the factorization out separately. So don't just stop after the x factor. Word of caution. So whenever you have a trinomial in standard form, like this one over here, x squared plus 7x plus 12, the key is that once I draw my x, as I've already done here, I have to find two things that multiply to give me the first term, ax squared, or in this case, just x squared. So these two spaces in the x factor have to multiply to give me the first term. So what are two things that multiply to give me x squared? That's right, x and x. Now, the other two spaces, here and here, must multiply to give me the last term, c. So what are two things that multiply to give me 12? 6 and 2? Alright, let's try that. Now here's the key, and I'm looking here. When you multiply across the diagonals and add the resulting two terms, you must get the middle term, bx, or in this case 7x. So I have to check to see if I've done this correctly. Multiply across the first diagonal, and I get 2x. Multiply across the second diagonal, and I get 6x. When I add those, I get 8x. So that is a big fat wrong, because I want to get 7x. So I have to try again. What are two other things that multiply to give me 12? 3 and 4? Alright, let's try that. So I check to see if the diagonals work out. 3 times x is 3x, multiplying across the one diagonal, and x times 4 is 4x, multiplying across the other diagonal. So yes, that does work. So we're done, right? Cool. No, remember I said it's just a graphic organizer, so you have to go back and use the graphic organizer to tell you how to factor. Now, something that might help you guys is every time that you have a number like this is positive 3. So let me just write that. It's positive 3. This is positive 4, so let me also write that. Positive 4. Once I've filled in the graphic organizer, I can look across the top to determine what my factors will be. Now, a trinomial will always factor as two binomials, and in this case, it's going to be x plus 3 times x plus 4. And I know that that's correct. How do I know that that's correct? Because I just checked in my head. But let's check this answer visually so you guys can see. Remember, factoring polynomials and multiplying polynomials are going in opposite directions. So if I multiply this expression, I should get back to what we started with up here. So let's do that. So I'm going to check my factorization. So x plus 3 times x plus 4. X times x is x squared. X times 4 is positive 4x. 3 times x is positive 3x. And 3 times 4 is positive 12. So combining like terms, I get x squared plus 7x plus 12. And cool. I see that that is the same as I got up here. So my factorization was correct. So all of that was just a check. The answer, or the factorization, of x squared plus 7x is this right here. The two binomials, x plus 3 times x plus 4. That's my answer. Alright, let's try a couple more. So it says factor each trinomial. So again, first two things have to multiply to give me the first term, which in this case is x squared. So what two things multiply to give me x squared? Yep, that's x and x. And now what are two things that multiply to give me negative 8? Oh, how about negative 4 and positive 2? So let's check the diagonals to see if they work. And I'm going to start writing diagonals check to clarify between the other type of check. So the diagonals, 2 times x, multiplying across this diagonal is 2x, and multiplying across the other diagonal, negative 4 times x is negative 4x. 2x minus 4x is negative 2x. Yep, that works, because that is the middle term here. So the factorization is x minus 4 times x plus 2. And remember, that comes from, let me use a different color. That comes from looking across the first row, in a sense, of the x factor and the second row of the x factor. I'm writing them each as a binomial in parentheses. Now remember, down here it says, don't forget to check your final answer by multiplying. So I'm going to check my final answer by multiplying. X minus 4, so this is my check, my answer check. X minus 4 times x plus 2, you guys are all bosses at multiplying binomials. So x times x is x squared. X times 2 is 2x. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. So that's x squared minus 2x minus 8, which is the same thing that I started with. So this red answer that I'm going to box is the correct answer. Now the next few examples I'm not going to write so much because I want you guys to get the process down and be able to come quicker at this. I love factoring trinomials. It's just really fun. Wouldn't you guys agree? Don't you say no. I heard you say that. You need to say yes like everyone else. Shout out to Tyler Harrison, who gave me the idea to make this video. Alright, so let's try the next example here. So what are two things that multiply to give me x squared? I'm looking at number 11. Again, it's x and x. And what are two things that multiply to give me 16? And when we're doing this, we also want to think that multiply to give me 16 and might add to give me the middle term once I do the diagonals. So 4 and 4, okay, positive 4, positive 4, they multiply to give me 16. So let's do the diagonals check. Diag check. That's 4x plus 4x looking across the diagonals, which is 8x, which is not right because I need negative 8x. So what could I do? How could I fix that? Well, I could use negative 4 and negative 4. That's right, because those still multiply to give me positive 16, but they add, when I do the diagonals, negative 4x minus 4x to give me negative 8x. Excellent. So again, this is just a graphic organizer to help me see that the factorization, the solution is x minus 4 times x minus 4. And I'll leave it up to you on this one to go through and verify that that is correct. Okay, let's try another one. Again, two things that multiply to give me x squared, looking at number 12, x and x. And then what are two things that multiply to give me 6 and might also add to give me 7? 6 and 1. Alright, so let's do the diagonals check. X times 6 is 6x. 1 times x is 1x. When I add those, I get 7x, which is what I needed there in the middle. So this factors as x, oh yeah, this is positive 6 and positive 1. So x plus 6 times x plus 1. Okay, let's try this last one. X squared minus 7x minus 30. Two things that multiply to negative 30. Well, let me not get ahead of myself, sorry. First, what multiplies to give me x squared, x and x. Good. Now two things that multiply to give me negative 30. I might also add, when I do the diagonals check, to give me negative 7x. How about negative 10 and positive 3? Let's check. I feel like a hockey coach. Let's check. Some of you guys didn't get that joke. It was a lame joke. Alright, give me a break. Anyways, looking across the diagonals, I get negative 10x and positive 3x. When I add those, that's negative 7x. So, bam, I know that's right. And this factors as x minus 10 times x plus 3. Okay, and now that you've got the hang of it, what I want you to do is pause the video and try 14, 15, 16, and 17 on your own. And then come back, and I'm kind of going to fly through these examples because I took my time on the other 4. So I'm going to fly through these just so you can check your answers. So pause the video right now, try these 4, and then come back to it. Alright, now that you've unpaused the video, I'm just going to fly through these like I said. Two things that multiply to give me x squared are x and x. Multiply to give me 10 and add to give me 7. Positive 5, positive 2. So this factors as x plus 5 times x plus 2. And again, I can check by multiplying these two binomials, and I should get what we started with, x squared plus 7x plus 10. Number 15, x and x multiplies to give me x squared. Two things that multiply to give me 5 and might add to give me negative 10. How about negative 5 and negative 5? So that factors as x minus 5 times x minus 5. And if you want to be a person who exercises math swag, you would write that as x minus 5 squared. That is called math swag, which I have. And I hope you do as well. Alright, number 16, let me change colors just because I like colors. X times x is x squared. And what are two things that multiply to give me negative 18 and could add to give me negative 7? How about negative 9 and positive 2? And again, on this one, I'm going to do it just so you don't forget how to do it. Diagonals check. Multiply across this diagonal. Negative 9 times x is negative 9x. Across this diagonal, x times 2 is positive 2x. When I add those two, I get negative 7x, which is, yep, what I need to start with. So this factors as x minus 9 times x plus 2. Okay, now I've got 17. X times x will give me x squared. And then I need two things that would multiply to give me positive 22 and might add to give me negative 9. How about negative 11 and positive 2? So this factors as x plus 2 and x minus 11. So again, the x factor is just the graphic organizer. Each of these products of binomials is my answer. And in this case, you could do that or this, depending on how much math swag you have. Alright, thanks for watching this video. If you want to check out the next one, it'll be about how to factor trinomials when the lead coefficient is something other than 1. Because notice that in all these examples we just did, it was 1. We just don't write the 1. Because remember, if it was 0, there would be nothing there. But since it's just x squared, we're talking about 1x squared. Because you see 1x squared right there. All right, have a great day. Hope that was helpful.